Hi, everyone. Welcome to Accidental Data Lies, How Poor Visual Choices Can Mislead. Before we get started, let me briefly introduce myself. My name is Juliana Smith. My background is actually in physical oceanography, so I started my career in ocean research. And since 2020, I have specialized in Power BI and user interface design. For the past 2 years, I have also deep dived into digital accessibility, and I currently work with project controls analytics. I have a blog and a YouTube channel where I share content on Power BI as well as accessible design. And then a big shout out to Redgate. Thanks a lot for hosting us today here in Amsterdam. So let's get started. I wanted to have a look at this image and try to think, what do you think you see here? Perhaps you've seen a vase, perhaps two faces, perhaps you're trying to figure out what is, I don't know, clever design, or if it's your mind playing tricks on you. Well, this is an optical illusion. An optical illusion plays with our perception, making us double guess what actually are we seeing. We start thinking, oh, is that really what I'm seeing? Now imagine if this was a data visualization. What if our data visualization did the same thing? What if instead of revealing insights, it tricked the viewer? Welcome to Accidental Data Lies. We will explore how well-meaning or not visualizations can intentionally or not mislead, confuse, or even manipulate. And it often starts with something as simple as the first impression. So we're going to uncover the tricks and traps and learn how to design visuals responsibly, making sure that we inform rather than mislead our audience. So we're going to talk about ethics in data visualization, and then about sampling bias. And then we're going to have some fun talking about the sneaky ways chart mislead. And then I'm going to talk about color abuse, the dreaded average of averages, and we're going to wrap up with storytelling and framing effect. So let's get started. So ethics in data visualization. Let's get started. Ethical visualizations present the data truthfully without, we don't mislead, we don't make our audience think that the things are not there actually are. So we avoid cherry picking data, we avoid deceptive design. And there are a few issues in terms of ethics in data visualizations. Some of them are misrepresentation, manipulation, and bias. And we're going to look into each one of these issues and see some real examples and what we can do to avoid misleading our audience. So let's get started with misrepresentation. And this is when the data is shown in a way that is not accurate, that can be by accident or not. Here, an example. This is from a news channel, Fox News, which gave me a lot of material for this session. And when we look at this visual here, it's about job loss by quarter. And there is an impression here that the job loss kept increasing steadily from December 2007 to June 2010. But let's have a look at the axis. You can see here that the first interval from December 2007 until September 2008 is about 275 days. And then we have from September 2008 until March 2009, and that's 181 days. But then for the last interval from March 2009 and June 2010, that interval increases to 457 days. So the axis is not realistic here. What they're doing, they are compressing longer intervals and expanding shorter ones. And that gives the impression that there is a steadily increase in the job loss. Now let's have a look at this visual where we have the axis correctly spaced. And you can see here, of course, there was a time that there was the most intense job loss. And then From, I don't know, after 2009, it was in a much slower pace. That perhaps was hitting even some early signs of stabilization. So we can see here what what was your first impression, and what actually was what the data was telling. So the data wasn't wrong. It was just how we represented the data. So that's why when time intervals are distorted, so is the story. So a proportional time axis ensures that the data trends reflect reality, not just a tidy visual. So always match your axis to your timeline. Next, we have manipulation. And this is when the data is changed or twisted to fit a certain story. I have here an example. It is a chart published by the Public Health from Georgia in the US. And it was about COVID-19 new cases. And COVID-19 as well, I don't know if it's quite recent, so you may remember, there were quite a few chart crimes. All sorts were done throughout COVID-19 to create a false sense of alarm. But let's have a look on this chart here. And you can see that there is, at first sight, there is a steadily decline in new cases. But let's have a closer look. Let's have a look at this axis. And you can see here that it's moving from the 2nd of May to the 7th of May and back to the 26th of April. So, and that happens across all the dates. So the dates are not in the chronological order. And that the way that this has been done is building this false impression that the cases are decreasing steadily when they may well not be actually decreasing. So let's have a look now. There was another publication that recreated this chart with the dates in the chronological order. And you can see here that perhaps maybe there was some of the cases were actually declining. It was not at the same pace. And the other trick done here, which is not ratified on the second visual, is the fact that each color, each bar represents a county, and they're not on the same order across the dates. And then, of course, that will help you building the impression of the decline in cases. So when we rearrange dates or when we shuffle categories in a way that hides the real trend, it crosses from poor design into intentional manipulation. So time-based data must follow consistent linear progression. You should always follow the chronological order. And then we have bias. And this is when the data is chosen or shown in a way that favors one side over another. And I have here this another example. It's a chart showing UK national debt in percentage. And based on this publication, you can see that the national debt reached a peak in, 2016. That is like a historic peak. But is that really what's happening here? This is another publication that they got the data from the same source, but it's showing the full timeline. And it starts in 1910 all the way to 2015. So let's say that this last part of this visual corresponds to the first one. And actually, the peak in the UK national debt was around the 1940s, not in 2016, as the other one was trying to give the impression. So cherry picking in data visualization means showing only the data that supports a narrative. In this case here, for whatever reason, they wanted to emphasize that the peak debt was in 2016. And by doing that, we hide the context that could shift interpretation. So if you show the whole picture, you will know that in 2016 was not even close to the actual peak. So this is a powerful bias. So we need to always aim to show the full timeline, especially when we have historical or long-term charts like this one. Now, speaking about bias, let's now talk about sampling bias. And this is one of the easiest ways that data can accidentally lie to us. So sampling bias happens when the sample we collect doesn't truly represent the whole population that we want to study. Now you might be thinking, well, I have nothing to do with data collection. Why are we talking about this? Well, it's very simple. As we are designing or analyzing this data, we have to make sure that our audience is aware of its limitations. So we're going to look now into a few types of sampling bias. There are various. I don't have time to talk about all of them, but I'm going to show you some of them, some real facts, and what we can do to avoid misleading our audience. So the first one is confirmation bias. So this is when the data being collected or the subset that we are analyzing reinforces an existing belief because the sample was chosen in a way that favors that belief. So I don't know if you ever try to say, oh, I think drinking too much water is really bad for your health. If you think about that and you start Googling, you obviously will start Googling about everything that reaffirms that your belief. You're not going to Google anything like, oh, drinking too much water does not make any harm, right? So that's pretty much what we're doing with confirmation bias. So here's an example, politics. This is the US election 1948. It was the main candidates was Truman and Dewey. And the pollsters stopped polling early because the results of the polls already aligned with what they expected. And they expected that Dewey would defeat Truman. And also they rely on sampling methods that overrepresented some groups. And these were the results of the polls that they had. You can see that in all of them, Dewey was going to win. But what actually happened? Well, as history says, actually Truman won. And that is what happened when we don't assess the data. We don't try to go through the critical thinking of, oh, is there anything that could contradict these information, something that goes against what I believe it is? So we always have to assess if the sample reflects the full population. So when we present the results, we need to be transparent about limitations. We should also avoid overstating certainty and ensure that visuals don't exaggerate a narrative that the data cannot fully support. Here we have now the non-response bias, which means that people who don't respond may differ significantly from those who do, and that will skew the results. Again, another example from politics. In this case, is the opinion polling from the for the 1992 general election here in the UK. And out of the 50 published polls, 38 were indicating that Labour would win. In some cases, it would have a narrow, but they were clearly leading the polls. And you can even see here this chart. The red line is Labour and blue is Conservative. And that's in the UK, we call them Tories. Here you can even see the results of each one of those polls. And you can see red is taken over. So there was no doubt that Labour would win. But what happened? Well, we have here that actually, so we have a map here of the UK, and blue again show the votes for Conservative, and they actually won. And they won by 7.5% difference. And I think it got everybody so flabbergasted that they got the Market Research Society involved. And what they found was that 2% out of the 7.5 error could be explained by the Conservative supporters not disclosing the intentions of their voting intentions. And that also happened on the exit polls. So after people voted, Labour was still leading. So this phenomenon was known as the shy Tory effect. So voters for Tory, so the Conservatives, they wouldn't say what they would vote for. And that was considerably different from those who responded. So we need to account for differences between respondents and non-respondents and clearly note how missing response may affect our insights. Next up is the survivorship bias. And this is where only successful or visible cases are analyzed, ignoring those that failed or dropped out. A very good example that I have on survivorship bias is the early studies on asbestos exposure. And those early studies would only focus on workers that were still employed and they were still healthy. So those who had already died from asbestos exposure illnesses, or those that were not working anymore because they were ill, they're not taken into consideration. And we all know now that actually asbestos-related asbestos exposure illnesses, they come much later in life. So that delayed the recognition of asbestos-related disease and also hindered the necessary regulatory actions to protect workers. So that happened as well, and affect way more than politics, affect many people's health. So we absolutely need to understand the data collection. So who might have been excluded and what that means for interpretation. So we need to be transparent about limitations. We have to avoid generalizing and clearly communicate when a data set only reflects those who survived the process. Now, let's have some fun talking about the sneaky ways chart can mislead. Let's get started with pie chart pandemonium. Some of you may agree, some of you may still like to use pie charts. So pie charts are used to represent the parts that make up a whole, also highlighting proportions, and they are inherently misleading. So they will mislead regardless of what you do. And why is that? It's because our perception, our visual perception is not very good at comparing areas. And it's particularly worse when we're talking about circular shapes, which is the case of the pie chart. And that means that even small gaps between two slices, for example, may look considerably bigger than they are. So on this very innocent pie chart, we have here category A with 35% and category B with 30%. And there is only a 5% difference. And even though category A looks much larger than the category B. So what happened is, at first impression, we may end up believing even more importance to larger slices than the smaller ones. And that will lead to a skewed interpretation, because we only rely on that visual perception actually than on the actual values. Next, under the pie chart pandemonium, I have here this survey that was Americans who have tried marijuana. And when you first look at this chart, you think the impression that you have, right? Because pie charts show the part of a whole, that 51% of the respondents said, we tried today, 43 responded last year, and 34 responded in 1997. But actually, these are different surveys. So each one of these surveys were done in different years, and they are, although they were different years, they are being represented on the same chart. So that will cause a lot of confusion. First of all, the audience may think that all these slides add up to 100%. In this case, they don't, but that's for the next slide. And because if they realize that it doesn't add up, your charts will instantly lose credibility. And also, we are trying to show and increase the trend of people who have tried marijuana. You're not doing that by using the pie chart. So something that is very, very important when we are designing data visualizations. We need to use the right chart for the right insight. In this case, a simple bar chart would be a better choice to show trend. And that's exactly what they wanted with these pie chart. Next, we have when 100% is not enough. So I have here, again, from COVID-19 news channel, they had the survey about biggest COVID-19 worries. And if you add up the three slices, you can see that it's way more than 100%. And that's because the survey allowed respondents to select multiple concerns, making the data non-mutually exclusive. And that violates the fundamental principle of a pie chart. They have to be mutually exclusive. And why this will be an issue? Well, your chart, again, will lose credibility because whenever your audience realizes that it's adding up to a more than 100%, they may think that there is something really, really wrong there. And whatever insight you're trying to show, it gets lost. Again, we have to use the right chart for the right insight. In this kind of survey, a Venn diagram, it is a much better choice than a pie chart. So pie charts, we shouldn't use it for everything. And then we have, I think everybody has seen something like this, when a pie chart has way too many slices. So you can see here, I cannot even count how many slices are here. And what this happens is your user, your audience will get overwhelmed. They will have difficulties to compare proportions, especially those smaller slices, and they may not even want to know what's happening here. So this is not the best type of visual to show when you have too many categories. So in this case, again, a bar chart would be much simpler and cleaner and easier to understand. Now we're going to move from pie charts. We can spend the whole day talking about pie chart crimes. But let's move to axis trickeries. And here we have small numbers, big ego. So if you see here, the candidate Gutierrez has 19%, and the one on the left, Petro, they has 37. And although 37 is bigger than 19 actually is looking bigger than 37, and 3% is also looking bigger than 27. And that happened because they used different axes to compare those two candidates. And that will give you a first impression. You may even think that Gutierrez is ahead. And whenever we have inconsistent scaling, that will distort the visual interpretation. That may cause exaggerate or downplay some trends. So in this case here, it's making look one of the candidates to have more popularity. So when we try to compare something like that, we should always use the same scale or at least shared axis. And then still on axis trickery, we have here two interesting visualizations. So the one on the left, with the average female height, it look quite funny, right? So you see here India and Latvia, oh wow, you laugh. But when we go to a more serious chart, that is this one also from Fox News, trying to make a point on the news, everybody watching, that can cause a bit of an issue. So both of these charts are omitting the baseline, and that means they are truncated graphs. And when we truncate a graph, it will exaggerate visual differences by compressing the scale. So of course, the average female height will laugh, but the chart from Fox News perhaps could cause quite a shock and mislead the audience. So you can see here, actually, it was only a 12% difference between 2009 and 2019, because the axis is starting at 58. Visually, the impression you have is the 77, there was a considerably bigger drop than actually there was. So if we omit the baseline, we need to clearly state the axis range and use proportional visual cues. We can also give the option to see the whole axis starting from 0, and then with the option to see with that truncated baseline. Because if you do that, I don't know, if maybe you're trying to show small variances, but depending on what you try to represent, line chart as well would be better, because it can show the change without exaggerating the magnitude. And now we have here the opposite, is when omitting the baseline is actually necessary. So we have average annual global temperatures in Fahrenheit from 1880 until 2015. And the way that is on this chart, the axis is starting from 0, which is far below the actual range of global temperatures. Again, this is in Fahrenheit, not in Celsius. And because it's far from the normal range of temperature, it is hiding manifold temperature change. So by looking at this chart, you may think that there is no global warming happening. Nothing, no, you're not gonna take it seriously. But from the moment that we actually get the axis closer to the range of global temperatures, you can clearly see there is a pattern of increasing the temperature. So, there is global warming. It's not like you're trying to hide, flattening, making the line look flat. So sometimes we need to omit the baseline to highlight meaningful variation, but we have still to clearly label the axis range and explain the choice in a caption or in a footnote, because these will ensure transparency and also help your audience to understand that the omission of the baseline was actually intentional. Next on axis trickery, it is here this very interesting chart, which is gun deaths in Florida. And you can see here, it seems that in 2005, they enacted the Stand Your Ground law. And the first impression that after that, there was a drop in gun deaths. But really, let's have a look what they did with the axis. It was inverted. So actually, after the 2005 law, there was an increase in gun deaths. And let's just invert this chart so you can see it better. And now you can clearly see there was nearly a 50% increase in gun deaths. So your audience will have the completely wrong impression, even though when the data clearly says that there was actually an increase. And apparently who designed this visual did not do that maliciously. And that's why I think it's very important to think it's really good. We always come up with new ideas how to design, how to use the same visual in different ways, but we have to be very careful. Innovation is great, but we always have to assess how the new design will impact perception and intuitive scanning. Remember, we're talking about the first impression. We're talking about people who may not understand data as well as we do. Next, we have scale fail. So when you think about what comes in your mind when I say UK and Venezuela, can you think about anything? Well, in this case here, they are united by bad axes. And again, politics, you can see here on the left side is a newspaper from the UK. And on the left side, it is the presidential election in Venezuela in 2013. And you can see here that the scale does not represent the actual numerical value. So there is no scale here between if you compare conservative with liberal Democrats. And, the same happens on the other chart. So it's quite a minor difference between 50.66 and 49.07. So there is no clear scale here. And that can mislead your audience in a blink of an eye. So just don't do it. Don't even think about, don't consider. Always make your scale explicit and consistent. Now let's talk about 3D chart distortion. So when we add a 3D effect, we add depth to that image. And that means that elements in the foreground, so elements placed in the front, may look bigger than the ones on the back, even when the values are similar or even when they are small. And that's because of this perception. And I'm going to show you here a very bad chart in many ways. It is showing three axes, so the year, the countries that export bananas, and I don't know what the other axis is. But if you look at that, how easily can you, Ecuador is clearly doing very well, but if you look at the bars that are overlapping each other, the ones that are angled, it's very difficult to judge size. Some of them you can barely see, like these here on the back. And then if you think the pie charts are bad, they get worse. They get worse when we add the 3D effect. And the tilt of this 3D effect will make something like this happen. will make the slices in the front look bigger, even when they're not. So we have here 19.5% looking considerably bigger than 21.2%. And the same happens here, which is a very interesting chart. But you can see that 44%, it looks bigger even than 82% and 62%. So avoid 3D charts because they will introduce depth and perspective that misalign visual cues with the actual values. Now let's talk about color abuse. So color is powerful, but with great power comes great responsibility. So first on the line is the unnecessary use of colors. That is when we use too many colors without a clear purpose. And we have here as a very good example, this bar chart with the least vaccinated counties. And although each one of the bars are labeled, they also have different colors without a clear purpose. So why would you label which would color each one of these bars differently? There is no reason here. Adding all these different colors is creating noise to a user who may struggle to understand what is the main site here. So we need to use color intentionally to keep our chart clear and focused. When we add unnecessary colors, we also introduce noise. We can also distract or confuse the audience. An intentional way of use of color in this example will be, for example, adding a neutral gray to all of the chart, all the bars, and you could highlight, I don't know, the least vaccinated county. So your user would see straight away what you're trying to show with this chart. Next, we have inconsistent use of colors. And we have here the same survey results from 2011 to 2012. How many nights do you typically stay away from home due to work? And of course, that's definitely not the best type of chart to illustrate the difference between 2 years. But let's have a look at the categories. So the first, here in 2012, the first category, fewer than 25, is represented with light blue. When we move back to 2011, that is actually green. And you can see it all across all the categories, they are all different. And that will cause a lot of confusion. It's going to be very difficult for your audience to compare what is actually happening, what is the difference. They may even see differences that are not really there because they're just judging on the color. So consistency in color use is key because it helps the audience to instantly recognize categories. Unexpected color changes can easily mislead them into seeing patterns or differences that are not there. Now we have reversing conventional color associations. Let's have a look at this map showing forest coverage in South America. And you might know that we have a large jungle in South America, the Amazon jungle, which is here in the north area, which is being illustrated as a light yellow. And at first, we're going to think, oh, wow, what's happening to the Amazon jungle? It's being destroyed. But actually, if we take a second look, what's happening here is that the colors are inverted. So a higher percentage of tree coverage is actually illustrated by this light yellow shade. And we typically associate dense forest coverage with darker green. So this is creating a cognitive dissonance, and it may cause a lot of people complaining. It's going to cause a lot of issue because they're going to think, oh, wow, we have to do something about it. Or if someone who knows what it should be like, it may just, think that, there is no credibility in this chart. So again, innovation is really good, but we have to assess how it will impact perception, especially when we already have conventional color associations. Now, talking about conventional color associations, we're going to talk about RAG colors, which are red, amber, and green. And we also have a condition that's color blindness, which affects 300 million people in the world. And the most common type of color blindness is the red and green color blindness. And this means that users who may have red or green color blindness, they may not see the difference between those colors very well. So you're going to be telling a story that your user may not see. So I have here this risk level map in the United States. And again, COVID-19, using RAG variation in colors. And I created a color blindness simulation that you can see here that some of these colors, they look the same on the map. So how can you make any decision based on that? And we absolutely love using RAG colors to report on performance and progress. I'm sure everybody has once conditional formatted using red, amber, and green. And a simple chart that rely entirely on the color, it may become very confusing or even unusual. Now imagine if you have to make a decision through those two simulations. So avoid color-only indicators, add alternative ways for your users to identify categories or measures, or you can make use of accessible colors, which are colors that there is enough contrast so you can see that there are different colors, and then you have to add the meaning of each color. Now let's talk about the dreaded average of averages. When we average multiple averages without considering the size or the weights of each group, we may give disproportionate influence on smaller groups. What does that mean? Let's have a look at a very simple example. So average work satisfaction score. We have Department A that the average score is 8.5, and Department B that the average score is 6. But you can see here that Department A has 200 employees. And Department B, where the score is lower, they only have 50 employees. If we simply average those two averages, it will give us the score of 7.25. But we are treating both departments in equal size, which they're not. So we are misrepresenting the overall satisfaction. A better approach, it is using the weighted average, where each group's average is multiplied by its size before combining. So each group will contribute proportionally to the result. So if you go back to our previous example, the first thing we have to do is, what is the total number of employees? And the maths is, we're going to get the 8.5, which is the score. We multiply by the number of employees for Department A. We do the same for Department B. We add the values and divide by 250. And we can see that actually the overall score is 8, not 7.25. Now, let's start wrapping up this session with storytelling and framing effect. So in storytelling, framing determines how audiences interpret and react to insight. So what is the concept? Framing effect is a cognitive bias where people's decisions are influenced by how information is presented or framed rather than by the information itself. Science has looked into it. There is this paper from 1981 that is quite important in terms of explaining how framing effect will shape our decisions. And one of the experiments on this paper was, imagine that the US is preparing for the outbreak of an unusual disease, which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Let's have a look on each one of these. The first group of people were presented a positive, so again, framing. So Program A, they said 200 people will be saved if we go to Program A. And Program B, 1 in 3 chances of saving 600 people, 2 in 3 chances that 600 will die. 72% chose Program A, and 28% chose Program B. But if you do the statistic behind it, the values are actually the same. And then on another group, they presented a negative or a loss framing. Where the Program C, they actually emphasized the number of deaths. So they said 400 people will die. And in Program D, they said 1 in 3 chances nobody will die, 2 in 3 chances that 600 will die. Again, the values behind is absolutely the same. So 22% chose program C, and program D had 78%. So the only difference is that the outcomes, how the outcomes are described in here. So in group one, it is described by the number of lives saved. So that's why everybody chose one of these program and one of the program. And then when we have group two, it was actually framed in terms of lives lost, and people's choice changed when the underlying probability were absolutely identical. So, and then we have the concept of positive versus negative framing, where highlighting positive outcomes often generates optimism, while emphasizing negatives can still caution or fear. So I don't know if you've gone through this before. If you see a mobile phone that costs £1,200 pay up front, you may think, oh, wow, no, I cannot afford that. And then if you have the option to pay installments, in this case, here, £50 a month, it sounds a much better idea. It sounds like a bargain. You may not even consider interest. Sometimes you pay interest when you pay installments. You may end up paying more than the actual value. But how it was offered to you, it looked a better choice. There is a very good example that actually inspired me to write this, to create this session. And it's the advertisement in London Underground in 2011, where they said that 99% of young Londoners do not commit serious violence. And it sounds very reassuring, right? Oh, wow, 99 does not commit. But let's look into these numbers. So at the time, the total population was about 8.2 million. Youth between 15 and 25 years old accounted for 12.5% of the population. So there are just over 1 million youth in London at the time. Let's see the violence estimate, which was 1%. So in total, there were 10,250 seriously violent young people in London. If I do this, 10,250 seriously violent young people in London in red. That may not sound as reassuring. If you've never been to London, if you don't know how big London is, you may think, oh, wow, is that a lot? Is it going to have 10,000 people around me who may commit serious violence? It may not, it's not as reassuring. This is from this fantastic book, The Art of Statistics, Learning from Data. And it opened my mind in various ways. And that's why, as I said, it gave me the idea to create this session. Now, we can see now that the way that we present data can unintentionally or not mislead or manipulate the audience. So how can we avoid misleading headlines? First of all, present absolute and relative values together. Showing raw numbers and percentages avoid misleading impressions. So instead of saying there was an increase of 50% in violence cases, you can say cases rose from 100 to 150%, 50% increase. Use neutral visuals and language. So avoid emotionally charged colors like red for danger, or words like alarming, explosive. So you don't need to say, oh, there was an explosion in case of violence. You can say there was an increase in violence case in the past 3 months. You are describing factually. You're not using any emotion here. Next one is provide context and benchmark. So framing is often amplified when data lacks comparison. So if you say, for example, oh, there are 10,000 violent cases of youth in London, it sounds different when you say compared to other similar cities that report between 12,000 and 15,000. So you can compare, oh, wow, hang on, 10,000. It seems to be okay, seems to be safer. And then as well, show multiple frames side by side. And this will help your audience to see how framing changes perception. So if you go back to our example of violent young in London, we have here, this was the original chart that I show you. That's not exactly what it was used in the underground, but how could we give more information about it? We can just add a little bit more context. You can say how many people accounted for the youth, and you can even say what was the 1% of serious cases. And if you add the benchmark here, cities in the similar size, how much they reported, your audience will be able to take informed decision. They will know the full picture. They will be able to make their own conclusions without being misled. So designing data visualizations is about communication. If our visuals are confusing, misleading, or overwhelming, we end up telling a story, telling the wrong story, even when we don't mean to. So remember, simplicity is our best friend. Embed ethical principles into every stage of design. Design responsibly with societal impact in focus. Check your axes. Use consistent and correct scales. Use the right chart for the right insight. And use color carefully and intentionally. Good data visualization is an act of respect for the truth and for our audience. Thank you very much. And I would just like to get your feedback, please. It really matters. If you could scan the QR code and evaluate the session, I'll be really, really grateful. Thank you very much.